Voyager 1 and 2 have just made a terrifying discovery that has thrown the entire space industry into shock. These space probes have been traveling in space for over 40 years, and they just discovered a weird sound in an explored space region. Could it be aliens making music? Join us as we explore how Voyager's terrifying new discovery shocks the entire industry.
And what they detected a few times is they detected these bulks or waves of plasma. 40, almost 50-year-old instrument is actually hearing these vibrations or energy from seemingly empty space.
Since its launch, the Voyager probes still orbit around space, making new discoveries like they were just launched a week ago. As the oldest flying spacecraft in history, they have helped improve scientists' research over the years. And now Voyager 1 has made another discovery, a signature of interstellar space, a faint plasma hum, which scientists compare to sound like mild rain. After its first mission of studying Jupiter's atmosphere, scientists have directed the spacecraft's tools towards a region in space that has not been explored before. After crossing the heliopause in 2012, Voyager 1 measured plasma in its new environment as it moved further from the Sun. Stella Koch-Ocker, a Cornell University doctoral student, commented on this discovery. The new research leader noted that Voyager 1's unique environment is very faint and monotone due to its narrow frequency bandwidth. As a result, they detected a soft, persistent hum of interstellar gas. However, the heliopause's solar wind pushes back every few years, making Voyager 1 pick up these occurrences as shock waves. At a time, scientists perceived those shocks as the only way Voyager 1 could measure the plasma density in its environment. But now that this faint hum has been heard by scientists, it would help them track the interstellar medium between shocks. This would make them know more about an unexplored space region. This faint hum also makes Ocker believe that the interstellar medium's activity is much lower than scientists thought. With this discovery, scientists do not need any event related to the Sun to measure interstellar plasma. Shami Chatterjee, a Cornell astronomer, explained that regardless of what the Sun does, Voyager would keep sending data. The spacecraft would continuously inform scientists about its current environment and the density around it. These twin probes are bound to explore space and make more discoveries. But scientists on Earth assume that the spacecraft's days are numbered, predicting the plutonium power sources will run dry sometime this decade. But till then, scientists would keep getting every bit of data it sends back, as it is the engineering gift to science that keeps on giving. Launched in the summer of 1977, the two interstellar probes began to make history by leaving Earth into space. 47 years later, these car-sized probes are still pushing on and making more discoveries for NASA. Contrary to their names, Voyager 2 was the first probe to be launched.
Off of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's senses farther into the...
While its twin Voyager 1 was launched some weeks later. These space explorers are equipped with a 12-foot antenna mounted on each, and they had one mission stated for them during their first launch. This mission was to visit the gas giants up in space and to send information about them back home. After they completed their missions, the spacecraft changed course. However, the divergence of these space probes turned out to be a historic achievement, as they took advantage of the rare planetary lineup that happened at the time. The spacecraft flew by Jupiter, Saturn, Neptune, and Uranus, and took mesmerizing photos, something any other spacecraft hasn't done efficiently. As they took more images, they sent information back to the scientists at NASA who studied them. The probes also discovered the planet's moons and attached enough photos of these moons before sending them back to NASA. By year's end in 1989, the mission was completed, or so scientists thought. Voyager 1 put the icing on the cake by taking a picture of our world in 1990, nicknamed the pale blue dot by astronomer and science communicator Carl Sagan. After these historical pictures were taken, National Aeronautic and Space Administration officials decided to send the Voyager 1 towards outer space, where it came in contact with something different. This made the spacecraft send the message back to scientists, who were baffled about this discovery. When scientists checked the readout from the attitude, articulation, and control system of the spacecraft, they saw that the spacecraft's movement and orientation were not aligned. This made the team of scientists handling Voyager 1's movement conclude that the spacecraft does not understand its location in space. Scientists assumed this since the AACS allows the spacecraft to send data about the environment in which it is located to NASA. With this malfunction, the spacecraft could not send its correct data, thus making it become a major concern to the officials. Suzanne Dodd, a project manager who had begun working at NASA's Jet Propulsion Laboratory in 1984, commented about the spacecraft's malfunction. She said this incident is not exactly a mystery, judging from the current stage of this Voyager mission. She said, "The spacecraft are both 47 years old, far beyond what the mission planners prepared them for." Thinking the issues might also be affecting the twin spacecraft, Voyager 2 was checked for any possible anomalies related to Voyager 1. When Voyager 2 was inspected, tests and data reverted from the spacecraft indicated that its operations were completely normal. After gathering all the data and trying to figure out what went wrong with Voyager 1, scientists discovered that Voyager 1's attitude, articulation, and control system was transmitting randomly generated data. This data needs to explain exactly what is happening on the interstellar probe. There are 3 computer systems on Voyager 1. Of all 3 computer systems, there is one that controls the spacecraft's orientation. The spacecraft's orientation keeps the Voyager's antenna directed towards Earth so that data keeps returning to NASA. The same computer is also responsible for controlling the spacecraft's thrusters. When scientists checked this data, they saw that the computer's telemetry signals didn't make sense. The signals from the computer were producing either all zeros or the number 377. However, Dodd mentioned that as long as this system anomaly doesn't make the old spacecraft go into safe mode, she said all is still well with the spacecraft. Dodd continued further, saying that if the spacecraft had a major issue, the team would have started experiencing a decline in the signal coming from the spacecraft. There was no decline or degradation, which seemed to be a good sign. The spacecraft was diagnosed, and running the diagnosis comes in 2 parts. The first step was to find out the root of the issue about the spacecraft or to switch the details to some of the backup hardware. Still, one thing was certain about the Voyager spacecraft, despite its current issue. It would continue to be operated. With the steps to solve the spacecraft's issue in space, engineers and scientists at NASA looked into the situation and dived in to solve the problem. The diagnosis results showed that the attitude, articulation, and control system has been sending telemetry data to an onboard computer that had stopped functioning some years ago. Sending information to a non-functioning computer wasn't good enough, so the computer corrupted the information, leading to all zeros or the number 377 seen at NASA. Having seen the situation, the team of scientists came up with solutions that would solve the spacecraft's issue and would not pose a risk to its well-being. The scientists then moved by commanding the attitude, articulation, and control system to continue sending data back to the computer like before. The solution worked as the interstellar probe system returned to its optimal functions and data was sent to the right computer again. Although scientists are yet to unravel why the ARCS started to route telemetry data into the wrong computer. Some of the scientists on the team feel that the issue must have been caused by an error from a faulty command generated by another computer on the spacecraft. If that was truly the issue, it would be sure that the problem was coming from a different place on the spacecraft. The team of scientists also believed that this issue would not threaten the long-term health and future of Voyager 1, and they still wouldn't stop until they found out why the invalid data was derived from the spacecraft system. "We're happy to have the telemetry back," Dodd said when she announced the spacecraft's correction. "We'll do a full memory readout of the AACS and assess everything it's been doing. That will help us try to understand the problem that caused the telemetry issue in the first place. So we're cautiously optimistic, but we still have more investigating to do. We have heard from scientists and read in books that our solar system has no boundaries, but the Voyager spacecraft debunked this by coming in contact with one of the boundaries in space. In the 2000s, the spacecraft crossed a region in space known as the termination shock. The termination shock is a region where solar wind particles are slowed below the speed of sound. This results from the pressure from the gas and magnetic fields in interstellar space. The space probes crossed through the heliopause in the 2020s, the region that sets a boundary between the interstellar wind and the solar wind. Surprisingly, there are other boundaries they came in contact with. Voyager 1 and Voyager 2 were built to run on different energy sources. These nuclear-powered systems have kept them floating and exploring space for the past 47 years. The Voyager space probes are powered by radioisotope thermoelectric generators, known as RTGs. The radioisotope thermoelectric generator is what turns heat from the decay of radioactive material into electricity, which powers the Voyager spacecraft. Even though NASA's Voyager 2 was launched before Voyager 1, Voyager 1 exited the asteroid belt faster than its twin probe after taking a faster route. It overtook Voyager 2 on December 15, 1977. Voyager 1 started its Jovian imaging mission in April 1978, when it was 165 million miles away from Earth. When scientists studied the images sent back by January 1979 by the spacecraft, they compared it to the Pioneer flybys that took place in 1973 to 1974. The pictures showed Jupiter's atmosphere was more turbulent than the Pioneer flyby images. It also explored the planet of Io, where it took pictures of the planet and sent them back to scientists. The images showed a weird mix of yellow, orange, and brown worlds with at least 8 active volcanoes. These volcanoes were seen to spew materials into space, making it one of the most geologically active planetary bodies in the solar system. The discovery of this planet's components by Voyager 1 suggests the reason for the sulfur and oxygen found in Jovian space. As it continued its exploration, it discovered 2 moons, Thebe and Metis. But that's not all. When the space probe got to Jupiter, it explored the giant planet, its magnetosphere, and its moons more efficiently. The Voyager explored the planet more than the Pioneer spacecraft before it. It saw that Jupiter's atmosphere was more active compared to the records made by Pioneer 10 and 11. This discovery made scientists revisit the earlier atmospheric models, which could not explain the new features. One of the interesting things about Voyager 1's trip to Jupiter was the thin ring found around the planet. This discovery made Jupiter the second known planet to have a ring. Another discovery was on Io. Voyager 1 discovered that Io has extremely active volcanoes. These volcanoes are powered by heat generated by the stretching and relaxation of the moon, endures every 42 hours. This happens as its elliptical orbit brings it closer and far away from Jupiter. This remarkable discovery by Voyager 1 revolutionized scientists' concepts about the moons of outer planets. After studying Jupiter, Voyager 2 used the planet as a springboard to Saturn, using the gravity assist technique. The spacecraft took photos of the moons Europa, Callisto, Amalthea, and Io. The images of these moons gave a correct detail of their terrain for the first time. When the spacecraft approached Saturn in 1979, it found 5 new moons. During its flyby, it photographed Saturn's 5 moons: Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. When the moons were studied, all the moons seemed to be composed majorly of water ice. Voyager 1 was the second spacecraft to ever visit Saturn. On its visit, it explored the planet and its rings, moons, and magnetic field effectively unlike its predecessor, Pioneer 11. The now Interstellar made all its achievements and met all its set goals except for its photopolarimeter, which didn't operate. The photopolarimeter is one of 11 science experiments conducted by the Voyager spacecraft. The photopolarimeter is designed in a way to detect surface and atmospheric chemicals. It was used on Jupiter and its moons. As it moved further in its explorations, the spacecraft found 3 new moons: Prometheus, Pandora, and Atlas. Pandora is the shepherding moon that keeps the F ring well-defined, and Atlas is the moon that simply shepherds the A ring. The spacecraft took images of moons Mimas, Dione, Rhea, Enceladus, and Tethys. These images showed the beautiful structures of Saturn's good, complex, and wonderful ring system, and added the G ring to the known list of rings. The most interesting discovery by Voyager 1 has to be Titan, which passed on November 12, 1979, at about 4,000 kilometers. Images taken showed a thick atmosphere that covered the planet's surface. But after snooping around, the spacecraft saw that the moon's atmosphere was made up of 90% nitrogen. The pressure and temperature at Titan's surface were 1.6 atmospheres and minus 292 degrees Fahrenheit, respectively. When scientists studied Titan's atmosphere, results from the planet suggested that it might be the first body in the solar system apart from Earth that had liquid on its surface. The results also indicated the presence of methane, nitrogen, and more complex hydrocarbons on the planet. These discoveries meant that prebiotic chemical reactions were possible on the planet. Just like the way Voyager 1 used Jupiter's gravity to help reach Saturn, the spacecraft used a gravity-assisted Saturn to help change its course and increase its speed. This gave the spacecraft a trajectory to fly out of our solar system. With 4 instruments operating on Voyager 1 and 5 on Voyager 2, both space probes were given a different purpose. Since their first mission, the spacecraft was tasked with taking note of their environment. This includes measuring the magnetic field strength in the area, the density of plasma around the spacecraft, and the direction of charged particles in the spacecraft's location. The aim of this new mission given to the Voyager space probes is to measure the sun's effects as the space probes venture deeper into space and further away from Earth. With this, scientists and researchers on the Voyager interstellar mission at the Jet Propulsion Laboratory would learn more about interstellar space and how the sun's heliosphere interacts. Since Voyager's launch 47 years ago, the 2 interstellar probes have covered a distance that no other spacecraft has achieved. Voyager 1 is 14.6 billion miles from Earth, while Voyager 2 is 12.1 billion miles away. An unbeaten record was achieved by both spacecraft made by mankind. It is a remarkable coda for their mission, years after the spacecraft completed the main goals that took them to space. Their initial mission was supposed to last 4 years, and now the space probes are still going strong 47 years later. Despite this record achievement, the National Aeronautics and Space Administration continues to track their journey, and they keep responding by sending information about their environment back to NASA. The Voyager probes were preceded by the Pioneer missions. These Pioneer missions carried small metal plaques with symbolic messages. Although the Pioneer systems are no longer functioning, no other space mission has incorporated a similar record of humanity since then. NASA's New Horizons tried to offer another chance to Pioneer systems when it flew by Pluto in 2015. When scientific artist Lomberg was asked about the incident, he said it was a missed opportunity. He proposed another suggestion, though, that it might still be possible to send a digital message to the spacecraft's computer. That would be durable, but it would not last as long as the golden records. Each of the Voyager golden records consists of 115 analog encoded photographs, greetings in 55 different languages,
Bonjour tout le monde.
and a 12-minute montage of different sounds of the Earth. Also, these space probes carry 90 minutes of music on this Voyager golden record. But these are not the only things on the golden record. The team that put it together felt it was important to convey informally about human anatomy, so they drew diagrams from the 1978 edition of the World Book Encyclopedia. NASA also included the silhouette of a male and a pregnant female. So much for the golden record being our self-portrait, after all. As they tried to explain reproduction, NASA approved a drawing of the human organs and images that explain the concept of childbirth. The photo used to depict childbirth by NASA was the famous photograph of Wayne F. Miller's son. In addition, NASA and the golden record experts then picked silhouettes of the 2 figures, a male and a female, and a fetus positioned within the woman's womb. The photo was featured in Edward Steichen's 1955 Family of Men exhibition. The National Aeronautics and Space Administration also added details about how we humans live, such as a demonstration of us eating, licking, and drinking. When producers had issues getting a specific image in picture libraries from different organizations, NASA and the golden record experts had to create a version for the golden record. They tried to explain the malfunctions, for which they had an odd but informative picture of a woman licking and savoring an ice cream cone. There is also a photograph of a man taking a huge bite out of a sandwich and a thirsty-looking man drinking water in huge gulps from a jug. Information about the human body was not the only form of pictures uploaded on golden records. Some images were chosen based on the record they've set. not based on aesthetics, but on the amount of information they pass along and the clarity that comes along with the image. It seems strange that a pictorial illustration of Olympic sprinters was among the information compiled into the Golden Records. However, it is one of the most explanatory photographs that made the cut into the Golden Records. This is because the photograph shows several races of humans, explains the muscular nature of the human leg, and how it is used as a form of competition and entertainment. However, informational photos were not the only pieces of information that made up the Golden Record. The team responsible for details in the Golden Records added artifacts, such as the Taj Mahal. This is because photographs of huts, houses, and cityscapes were included in the Golden Record, so it would serve as an overview of the types of buildings constructed here on Earth. And for this purpose, the Taj Mahal was chosen as an example of very impressive architecture. This sounds baffling compared to the other types of buildings and monuments. However, the Taj Mahal was picked over huge definition buildings like cathedrals, Mayan pyramids, and other structures. This is because Mughal Emperor Shah Jahan built the Taj Mahal in honor of his late wife, Mumtaz Mahal, and not for a god. In the Golden Records, 3/4 of the disc was devoted to music and sounds of all kinds, so visual art was not exactly a priority to the team that put it all together. Despite that, some photographs taken by the iconic photographer Ansel Adams were selected to be included in the Golden Records. They were selected not just because of the photographs themselves, but for the details captured within their frames. One such image is the Golden Gate Bridge from nearby Baker Beach. The image was chosen because it was thought to clearly show how a suspension bridge connected two pieces of land separated by water. The sound of an automobile was also included in the record's sound montage, but the producers could not overlay the sounds and images. The Voyager spacecraft have created a beautiful influence on space exploration since its first discovery. Their success inspired NASA and other agencies to visit other planets again. Planets like Jupiter, Saturn, and their myriad moons were visited again and studied. These missions featured Galileo, Juno, Cassini, and the European Space Agency's Huygens lander. New probes were also added to the subsequent missions, such as the Europa Clipper, Dragonfly, ESA's JUICE, and potential voyages to Uranus and Saturn's moon Enceladus. The interstellar spacecraft did not just have a huge influence on space exploration, but also influenced pop culture. The first Star Trek movie in 1979 featured an alien called Voyager, which is actually an altered fictional Voyager 6. The Voyager spacecraft and Golden Records have also been discussed in TV shows like Saturday Night Live.
It may be just 4 simple words, but it is the first positive proof that other intelligent beings inhabit the universe.
The West Wing,
Hey, you want to hear something cool? Voyager 1 just crossed the termination shock 8 billion miles away. First human-made object to leave the solar system.
and the one we all know, The X-Files.
Do you know the significance of this piece?
Well, recalling music appreciation with Professor Gans, Bach had a genius for polyphonic.
This is the first selection of music on the Voyager spacecraft. The first. 4.5 billion years from now, when the sun exhausts its fuel and swells to engulf the Earth, this expression will still be out there, traveling 4.5 billion years.
The composer Dario Marianelli even wrote a Voyager-inspired violin concerto. Scientists believe the Voyager spacecraft might stop working this decade after 47 years of service and giving scientists the biggest breakthrough discoveries ever known to mankind. In June 2012, Voyager 1 was detected to be almost out of the heliopause and was about to enter interstellar space. A year later, in September 2013, NASA announced that Voyager 1 had crossed the heliopause into interstellar space on the 25th of August 2012, making it the first spacecraft to achieve this feat. Voyager 2 was right behind Voyager 1 and became the second spacecraft to cross into interstellar space on November 5th, 2018. Although it took some time, this means that a one-way signal sent to Voyager 1 takes an estimated 21.5 hours to get there. Simply put, it explains that the signals are traveling a distance of 14 billion miles away from Earth. From recent data collected, Voyager 1 was moving with a speed of 61,185 kilometers per hour and was 23,252,000,000 kilometers from the Sun, which is a distance of 14.6 billion miles away from Earth. The Voyager 2 probe was also moving at a velocity of 55,335 kilometers per hour and was 19,350,000,000 kilometers from the Sun, a distance of 12.1 billion miles away from Earth. Isn't that mind-blowing? The certified space soarer has been orbiting in space for the past 47 years. And as it keeps progressing and moving further into deep space with its system operations, scientists observed that the iconic spacecraft, Voyager 1, has issued a couple of strange system data. With the readout coming from the attitude, articulation, and control system of the spacecraft, it seemed that the movements of the spacecraft and its orientation were not in alignment. This further brought about the theory that Voyager 1 is unclear about its location in space. This assumption was made because the AACS is what enables the spacecraft to send data about the environment it's in to NASA, and now it couldn't send the correct data. This became a major concern. A mystery like this is sort of par for the course at this stage of the Voyager mission, said Suzanne Dodd, who started working at NASA's Jet Propulsion Laboratory in California as a project manager on the Voyager 1 and 2 spacecraft, right as she graduated out of college in 1984. She said further, "The spacecraft are both 47 years old, which is far beyond what the mission planners prepared them for. And when Voyager 1's twin, the Voyager 2 probe, was checked, tests and data returned from Voyager 2 showed that its system operations are normal. From the data that the scientists at NASA gathered, they saw that Voyager 1's attitude, articulation, and control system is sending data that is randomly generated, and the data does not explain the actual details of what is happening on board the interstellar probe. Of all the 3 systems on Voyager 1, the computer system is the one that controls the orientation of the spacecraft, such as keeping the spacecraft's antenna pointed towards Earth in order to ensure that data from Voyager 1 keeps coming back to NASA, and it is also the same computer that deals with controlling the thrusters of the spacecraft. Only the telemetry signals does not make any sense, and it's producing either all zeros or the number 377. But since the system issue hasn't made the old spacecraft go into safe mode, all is still well with the spacecraft," Dodd said in a statement. "If the spacecraft was in appalling conditions, we would be seeing a degradation in our signal from the spacecraft, which they didn't see." She said further that diagnosing the problem would come in 2 steps, which is finding out the root cause of the issue, because that is what would judge the next steps to be taken, whether to reset anything on the spacecraft or to switch to some of the backup hardware. But one thing was certain: the Voyager 1 would continue to be operated. However, the engineers and scientists at NASA looked into the situation and moved in to fix the problem. They discovered that the attitude, articulation, and control system had been sending telemetry data through an onboard computer that was known to have stopped functioning years ago, so the computer corrupted the information. When the team noticed that this was the situation at hand, they decided to try a solution that wouldn't pose a great risk. They commanded the attitude, articulation, and control system to resume sending the data back to the right computer as it had always been. This step worked, as it corrected the issue and set the systems of the interstellar probe back to their usual functions, and data was sent to the right computer once again. Although engineers do not yet understand why the AACS started to route telemetry data into another incorrect computer, assumptions were made that it could have been an error from a faulty command generated by another onboard computer. If that was the problem, then they would be certain that the issue is coming from a different place on the spacecraft. The team would not stop until the root cause of the invalid data is found, but they believe that the issue cannot be a threat to the long-term health and future of Voyager 1. Regardless, we have to appreciate these probes because they have lasted so long. They are in a region where no spacecraft has reached before. Yet Voyager 1 and Voyager 2 keep pushing further, breaking limits and creating historical images. One such photo is this Voyager 1 image of Jupiter's moon, Dima Io. Source, Image 4. Io is the most geologically active place in the solar system, and if astronomers were to vote for the most un-Earth-like world, Io would be among the top 1%. Another thing is that Io has one bizarre feature: volcanoes, Not just one, but a huge amount scattered across the planet. Those volcanoes formed due to the planet's huge gravity that stretches Io's interior in a process called tidal heating. This process melts rock into liquid magma, which then finally builds up enough pressure before bursting to the surface. Due to the massive quantity of volcanoes on Jupiter's moon, it looks like a huge ball of cheese or somewhat related to a terribly unappealing pizza. It must have been puzzling to discover that there are volcanoes outside our planet. But when NASA took this photo source, Image 4, and studied it to see if it's active or not, they knew at once that it must not be revealed to the public. What did they see? The photo was taken by Voyager 1 and studied by the officials at NASA, and it showed one of the active plumes of the volcano Loki. Active volcanoes are not something we hear of often in our solar system because space is mostly filled with objects that are geologically dead. But when the Voyager spacecraft explored Io in the late 70s, it discovered more than 5 active eruptions during its flyby. It even captured one on film. Since then, more than 150 active volcanoes have been detected and mapped, and about 400 are theorized to exist. Of all these volcanoes outside our planet, the most impressive of these volcanoes is the one called Loki. Named after the Norse god of mischief, Loki might not be the biggest volcano in our solar system, but it is the most powerful to exist, without a doubt. This volcano has a groundbreaking diameter of 202 kilometers, but the molten underground lava lake feeding Loki, its material is what mesmerizes scientists and astronomers. Due to this, Io is capable of shooting lava with enough power that can send it hundreds of miles into space. Loki's power is one that got the attention of the entire science world upon discovery, and as a result is often watched by scientists and astronomers. You might think that the reason why Io's most powerful volcano is often watched is due to its eruptions. Well, yes, but not for that exact reason. Loki likes to keep to a schedule when it comes to its eruptions, as astronomers have noticed, and if their speculations are correct, it would erupt soon, and it might be more powerful this time. For a volcano that shoots lava hundreds of miles into space, imagine how far it would shoot lava during its most powerful phase. Julie Rathbun, a senior scientist at the Planetary Science Institute, once displayed a poster at a congress in Geneva. This poster showed how easy it is to predict Io's eruptions, as the volcano is so bright in the infrared that telescopes on the Earth can easily detect it. This is completely true because studies over the last 2 decades have depicted that Loki brightens during eruptions. In the 1990s, Loki was studied, and scientists found out that it erupts every 540 days. When recent studies were carried out, it was seen to occur every 475 days. This was a prediction that Rathbun made correctly, but not all predictions correlate easily. It is usually hard to predict the eruptions of volcanoes due to several factors that can cause eruptions. But Loki is different. We think that Loki could be predictable because it is so large, Rathbun said. Because of its size, basic physics are likely to dominate when it erupts, so the small complications that affect smaller volcanoes are likely to not affect Loki as much. Still, Loki is not rigid, and even Rathbun, who once predicted its eruptions, acknowledged it. Loki is named after a trickster god, and the volcano has not been known to behave itself, Rathbun said in a statement. In the early 2000s, once the 540-day pattern was detected, Loki's behavior changed and did not exhibit periodic behavior again until about 2013. So you see, the volcano lives up to its name, but scientists were still not ready to give up. That birthed a new study in which Catherine DeClear, a planetary scientist, and her team examined 3 decades of observation of the ebb and flow of Loki. It was done in a bid to find patterns that might explain the volcano's schedule of activity to Io's orbit around Jupiter. Some people are expecting Io's volcanoes to do something like this, and it's not too surprising, lead author Catherine DeClear noted in a statement. But then there are other people who think that volcanoes are so complicated that they wouldn't necessarily follow these orbital trends. DeClear and her colleagues started by pinning down the details of Io's orbit, which takes about 1.77 Earth days. That's too fast for scientists to develop a nuanced understanding of the orbit's impacts using Earth-based telescopes, which can only observe when Io is in their line of sight. But there are other, much slower cycles, on the scale of hundreds of days, that are embedded within that orbit as other moons pull at Io. Those cycles could also influence the tidal heating that the moon experiences. It's been this interesting search for patterns in the volcanic activity. Tidal heating should produce volcanism that follows specific patterns, DeClear said. So you should have volcanoes that are occurring at specific places on the surface and not at other places, and you might expect them to show specific patterns in time also. As they tried to make sense of the volcano, the study authors gathered all the observations they could find of Loki over the past 3 decades. For much of that timeline, scientists' data was sporadic at best. But in 2013, DeClear and her colleagues made a concerted effort to maximize observations of Loki. The result is the most detailed look scientists have ever had at the volcano's activity. It's the data set which is the most impressive thing. Julie Rathbun, who wasn't involved in the new research, but who also studies Loki, said in a statement, "It's really hard to get all the data we want from the ground." The other factor that DeClear and her colleagues focused on was that the details of Io's orbit around Jupiter were less challenging to study. But it's not the sort of factor volcanologists might turn to first if they've been inspired primarily by volcanoes closer to home, which aren't strongly affected by any tidal heating. A lot of the geology is based on terrestrial geology, and there's not a lot of things on Earth that are driven by tides, so it's not something I think people, especially when studying volcanoes, are used to looking for, Rathbun said. When studying planets and moons, tides and periodicity are among the most obvious things to measure. They're the easiest things to measure. DeClear and her colleagues were inspired by cycles scientists who have noticed plumes streaming off one of Saturn's moons, Enceladus, which seemed to brighten and dim in conjunction with that moon's orbit. They found 2 cycles in Loki's activity that might be influenced by tidal heating, one lasting 454 days and the other 480 days. Both of those numbers are close to cycles in which Io's orbit is tweaked by the influences of its neighbors. And realistically, that sort of cycle might make more sense in a volcano than a cycle tied directly to an orbital period as fast as Io's. Those are the timescales that a volcano can actually evolve on, DeClear said. She and her colleagues think one potential explanation for what's happening at Loki is that the plumbing of the volcano can't respond to tidal heating at the speed of the 1.77-day orbital cycle, leaving only slower cycles to affect the volcano. Understanding how Loki works isn't just about understanding one massive planet's weirdo moon. Earth and Io are the only worlds in our solar system where it's easy to study volcanoes, and Earths aren't strongly influenced by tidal heating, but scientists believe that phenomenon is a vitally important one in the bigger picture of planetary science in our solar system and beyond. This kind of global-scale, tidally driven geophysics is just not something that you have on Earth, DeClear said. Io is kind of this alien world where we have these processes that you're not able to study on Earth, and if we can study them on Io, we can broaden our idea of geophysics more generally so that it's less Earth-centric and encompasses more worlds. DeClear and her colleagues are hoping to continue regularly checking on Loki in order to sort out how Io's orbital cycles are governing its activity. They calculated when the volcano could rumble based on each timeline. Within a few years, they're hoping to gather enough data to pin down a better understanding of Loki's dynamics. It's going to be a lot of fun when we get close to the predicted times that the brightening should occur, DeClear said. We can watch and we notice right away in the images when Loki starts to brighten, and that's always fun. Before it was discovered, astronomers had suspected that planet Neptune, now categorized as the outermost major planet, had rings. After all, the next planet inward, Uranus, had rings found in 1977, as well as Jupiter's, which was found in 1979, and Saturn's. Watching from Earth in 1984, astronomers recorded extra blinks before and after Neptune passed in front of a distant star. They were caused by the ring material blocking the star's light, but it was NASA's Voyager 2 spacecraft that provided the first photographic proof of the existence of Neptune's rings on August 22, 1989. At the time, the spacecraft was a few days out from its closest encounter with the planet. As Neptune began looming large in Voyager's cameras, the spacecraft photographed a faint but continuous ring system encircling the planet. The images of Neptune's rings confirmed astronomers' long-held suspicions. Today, Voyager 2 remains the only earthly spacecraft to have encountered Neptune. But since Voyager's 1989 flyby, the Hubble Space Telescope and Earth-based telescopes have imaged the two brightest rings of Neptune. Astronomers name those two Neptunian rings Adams and Leverrier. They're named for John Couch Adams and Urbain Jean-Joseph Leverrier, whose independent calculations helped find Neptune's position in the sky, and this led to its discovery in 1846. The NASA Solar System exploration also explained that there are names for three more rings of Neptune, which were discovered later. Starting near the planet and moving outward, the main rings are named Galley, Leverrier, Lassell, Arago, and Adams. The rings are thought to be relatively young and short-lived. So today we know that Neptune has at least 5 main rings. Plus it has 4 prominent ring arcs. The arcs are peculiar clumps of dust, and astronomers struggle to understand their existence because the laws of motion predict these arcs should spread out into a uniform ring over short timescales. Scientists now believe the gravitational effects of Galatea, a moon just inward from the ring, confine the arcs. There are also our prominent arcs located in the outermost rings, and they have names too. Astronomers call them Liberty, Equality, Fraternity, and Courage. They're located in the outermost ring, Adams. During the encounter, the engineering team carefully changed the probe's direction and speed so that it could do a close flyby of the planet's largest moon, Triton. The flyby showed evidence of geologically young surfaces and active geysers spewing material skyward. This indicated that Triton was not simply a solid ball of ice, even though it had the lowest surface temperature of any natural body observed by Voyager, which is minus 235 degrees Celsius. This discovery made by Voyager 2 opened the eyes of humanity to explore space further as the National Aeronautics and Space Administration expressed further interest in going back to Triton and studying it more. The NASA flyby mission, dubbed Trident, may be rife with liquid nitrogen geysers in its southern hemisphere. Or at least that's what was revealed on NASA's Voyager 2 mission's closest approach to Triton in 1989, when it captured a beguiling mosaic of images from this frozen world. If so, a 2038 Trident flyby could tell us a lot more about the source of this volcanism. Scientists and even geologists are particularly interested in how Triton's bizarre landforms are created and whether this strange moon contains an ocean. This inquisitiveness is part of the great steps leading to a leap in humanity's space exploration, and in the process, it created another historical experience by meeting Uranus. On January 24, 1986, the Voyager 2 spacecraft swept past Uranus, the solar system's remote 7th planet. The craft came within 50,640 miles, 81,500 kilometers, of its icy blue-green cloud tops. As a result, Voyager 2 became the first, and so far the only human craft to visit this planet. During its closest approach and in the weeks before and after, Voyager 2 transmitted a treasure trove of scientific data that utterly changed our view of this enigmatic distant world. Many remarkable discoveries came from this cosmic meetup. Data from Voyager 2 revealed that a Uranian day is just 17 hours and 14 minutes long. It showed that Uranus's atmosphere is similar to that of the other gas giants, composed mainly of hydrogen and helium. Below that lay water, ammonia, and methane ice. Scientists knew from telescopic observations made from Earth before Voyager 2 met Uranus that the planet's rotation axis was tilted at 98 degrees. In other words, the planet's polar axis lies almost in the plane of its orbit. Scientists think a collision with a planet-sized object early in the solar system's history tipped Uranus on its side. As a result, Uranus has perhaps the most interesting seasonal patterns in the solar system. Voyager 2 also revealed that Uranus has a bizarre magnetic field. The planet's magnetic field tilts 59 degrees from Uranus's axis of rotation, and it creates a non-uniform magnetic field for Uranus that can vary in strength by up to 10 times. Voyager 2 found that Uranus has radiation belts similar in intensity to those of Saturn. Earth also has radiation belts, with the two main ones known as the Van Allen belts. Voyager 2 met not only Uranus but its many moons. Initially, scientists discovered 10 new moons in the data Voyager 2 sent back, for a total of 15 moons known at the time. In 1999, additional analysis of Voyager 2 data revealed an 11th moon. Today, we know of 27 moons orbiting Uranus. Among the newly discovered moons was Puck, just 160 kilometers in diameter, with a gray, heavily cratered surface. Voyager 2 also imaged the Uranian moons we already knew, revealing their amazing geology. The last Uranian moon discovered before Voyager 2's arrival was Miranda. Gerard Kuiper found it in 1948. Thanks to Voyager 2, we saw Miranda much more clearly. In fact, it earned the nickname Frankenstein Moon because of its strange patchwork appearance. By the time Voyager 2 met Uranus, scientists had already discovered Uranus's rings from Earth. Voyager 2 surveyed Uranus's rings and discovered 2 new ones, bringing the total number of rings to 11. Today, there are 13 known rings, and so Voyager 2 vastly increased our knowledge of Uranus and then left this world behind for one final rendezvous with Neptune in August 1989 before heading out of the solar system. In December 2018, NASA announced that Voyager 2 had entered interstellar space. Now, 44 years after it launched from Cape Canaveral in 1977, the spacecraft is almost 19.3 billion kilometers away from home. This iconic Voyager 2 encounter still remains relevant today as scientists keep on studying it. In the process, they uncovered a new mystery about Uranus's rings, buried deep in data from NASA's iconic Voyager 2 mission. Voyager 2 flew past Uranus in January 1986, discovering 10 moons and 2 rings, while becoming the first and so far only spacecraft to visit the ice giant. One of those rings, which scientists call the Zeta Ring, has frustrated astronomers ever since. They weren't even able to spot it again for nearly 2 decades. But last year, researchers got an unexpected gift, a new image of the Uranus's ring system, including the elusive Zeta Ring. For a long time, we thought we only had 2 images of this ring from Voyager 2. Matthew Hedman, a planetary scientist at the University of Idaho, said during a presentation at the annual meeting of the American Astronomical Society's Division of Planetary Sciences. This shows there's a lot of information still encoded in the Voyager data that deserves a second look. Scientists originally missed the find because the reddish dusty ring closest to Uranus wasn't visible in any individual image. So Reagan had to combine a host of images together for the feature to appear. He took hundreds of images, stacked them together to produce this image of the Uranian system. Hedman said, "This is the most comprehensive view of the Zeta Ring that exists, and we didn't know it was in the Voyager data for decades." The new image, combined with the previous 2 Voyager photographs, offered Hedman and his colleagues enough information to calculate the ring's distance from Uranus, about 37,000 kilometers above the planet, and to estimate its brightness. But both of those values are puzzling. The Keck Observatory in Hawaii had gathered the first observations of the Zeta Ring since Voyager 2 in 2007. These observations showed the ring at 40,000 kilometers above the planet, a bit farther from Uranus than the Voyager 2 observations showed. The trick is that the location of this ring didn't match the Voyager images, Hedman said of the Keck observations. Something had changed about this ring over the course of 20 years. We're still not entirely sure what that was, though. And the Zeta Ring didn't just inch away from the planet during those 2 decades, it went unmonitored. It also registered a stronger signal in the Keck observations than it had in Voyager 2's view. It got significantly brighter, which means dust got introduced to the system sometime in those 20 years, Hedman said. Now, what did that happen? We have no idea. Hedman suggested that Uranus could have been hit by a space rock that fragmented into debris and settled in the Zeta Ring, or that perhaps the changing seasons could be responsible, but both are merely ideas. Whatever happened must have been dramatic enough to affect the rings, but also have slipped under scientists' radar. NASA will begin planning a major mission to explore the Uranus system in the coming years, but scientists won't have data from that mission for a couple of decades. However, Hedman noted that the James Webb Space Telescope had captured a dazzling image of similar rings around Neptune, released in September. Fortunately, there is a telescope that seems to be very good at looking at dusty rings around planets, he said, so that might be nice. The discoveries made by these twin interstellar space probes are definitely one for the books, and the pictures taken by them just cement the value they have added to the world of science and astronomy. It also helps scientists to study the final frontier better, especially with the discovery of an active volcano located on Jupiter's moon. Hold on, if we can see bizarre photos like an active volcano spewing lava into space, then what if there are more weird photos that NASA is hiding away from the public? What do you think about these discoveries made by Voyager? Let us know your thoughts in the comments below.